Now we moved into the attack called DeepFool attack. What is DeepFool attack? So here, what that tool DeepFool is, what it is going to do with that model is smallest perturbation, that smallest change across some area so that the classifier, who is the classifier? The model will classify which one goes and which one is not. So I will tell you something. So that is ice cream parlor. Okay, the ice cream parlor, they have they are using some AI models. What they are trying to use, that they want to identify which flavor that ice cream. So I have ice cream with me, like one white. How that model predicts those ice creams? Like if it is a vanilla, that will be white. If it is a chocolate, then it's a brown. What the attacker here is trying to do here is, so he has ice cream, and with that ice cream, what he is trying to do here, he has a coffee beans, okay, slight coffee beans, and he is adding the coffee beans on top of the, it's like not much, it's only slightly. So what is the motto of this attack is, we are not going to use like lot of changes. We are going to do some smallest changes, very slight changes in that image, so that we are trying to confuse the AI. Okay, what that attacker is trying to do, he used the ice cream, vanilla ice cream, just have some few coffee beans, which represents in brown color. He add on the top of it, small, not heavy, very small, and then he has some brown powder. That's brown powder is like coffee powder, right? Coffee powder. He has taken something, and above on top of that, he has slightly. He has added, not much, slightly. Okay, but as a people, like a normal person, it looks like a vanilla flavor. We don't see huge changes in that. But what this guy is trying to do is show it to the AI model. Okay, what that AI model predicts that as, it's a chocolate flavor. Okay, so this is how DeepFool attack works. We have the, because we are continuously changing the behavior of the AI model. We have the ice cream with vanilla flavor. By making some smallest changes in the picture, we confuse the AI and make that to predict as chocolate flavor. In such a way, it works. Okay, so okay. So what happens if you see in the there are multiple models. Here we are using the ResNet model. There is we use some CIFAR model. We can use some, there's some data sets. You see model will be there. Data sets will be used to feed that model. Okay, we take some images from the ImageNet or maybe in the CIFAR. Okay, so now what we do, we try to make this tool run. Once this tool runs, okay, so what this does is, it makes some calculated changes here. It makes some calculated changes here, so that it makes the AI confusion. Make it as a confuse and predict that as a wrong. That's a CIFAR or maybe the image. Okay, so with that we see here. See here, we are using the same ResNet model, and then we use the ResNet model here, and then we use the image. If you see the second one, image is same single image. So you can use multiple images. There is no worry there, because here I use only one model, only one image. You can use looping. You can use a loop. You can use 100 images. You try to upload 100 images and test the models. Here we are in the bottom. If you see the attack which I am going to use, the full box attack, L2 DeepFool attack. I call that attack. Okay, so we have already installed. We have the programs we are trying to use. So if you have a front end, what's the difference, right? We can upload it. So we are working on the front end. It will be simple. Just upload the image. We call that what model we are going to use. Run it. Then it will attack and tell you the result. Okay, since we are working only on the background, backend, we are showing the codes. Okay, so the image I'm using one. For your flexibility, you can use n number of images. Okay, okay. Then now we are going for the practicals. Okay, Mukesh, please share your screen. Okay, this is the third one which we have worked. Sorry, fourth one. DeepFool attack. Okay, see, the model which we have used is ResNet 50. That's a pre-trained model. It's the same for everything. You can use any models. Here the input, what model which you are going to test. That model you have to use it here. Then as usual, we have wrapped the model with the full box. Then go for the attack. So we have used the transforms and everything, transformers, everything we have used here. So this is the attack. See, if you see curiously, if you see that one, see whatever the changes we have made, you will be able to identify. EFP attacks, full box attacks, use the PGD, spatial, PGD, and then spatial attacks, FGSM. Now we are using the fourth one, DeepFool attack, L2 DeepFool attack. Okay, now we are going to run this attack. Just please run that. Python deep.py. Now we run this attack. It's running. Okay, so there are certain attacks which take some time. Okay, not everyone. Certain we see that spatial and then FGSM and all. It suddenly became the results came immediately. But for certain attacks that take some time. Okay, if you see that 1, 3, 2, 24, 2 to 4, it's like we have a different types of methods we do use. At the end, you will see the results. Okay, let's wait for some time to get the result. So we have 2 more attacks pending. So we see how the time permits. Yeah, so we got the image. Okay, so the original image is one, and the adversarial image is the next one. We have pushed the adversarial image, but what's the difference here? If you see the left side, the attack success, if you watch that, the attack success is false. Original label is 920, adversarial label is 962. You see that that's the identification number the model has been provided, but what thinks the attack success is false. The model is resilient to that attack. Okay, we made some changes and for all these gradients and everything we have done. We have made some changes, calculated change over there, but AI found that no, this is a single image. There is no adversarial image. It didn't confuse. Okay, so previously what we have observed, whatever attacks we run, it was true. Okay, the model has been failed. The same model, the ResNet 50 we have used, the same model is failed. But now what happens? It is success. So the model withstand for this attack. See, the attack success false. The original label is this. The adversarial label is this one. Okay, so great. Take care.